Hello, welcome. This is the second part of our DevTools tips and tricks. So in this part, we're going to take a look at some of the internals or some of the ways you can extend DevTools or even use it in different ways for different applications entirely, which I think is very cool. So once again, you can follow along by going to bit.ly DevTools tips. You can see the slides, you can see the examples, you can follow the links. But in the meantime, just check out some of the things that you can do with DevTools. So the first thing that we talked about in the previous episode when we actually looked at DevTools was the Audit Panel. And the really cool part about the Audit Panel, we saw a couple of built-in audits like network and performance, but you can add your own functionality into here, which is really nice. So if you have any sort of style guidelines or team best practices or other things that you have kind of agreement on with your team, you can actually codify them into this plugin, inject them right into DevTools, and just hit run and it'll verify. So for example, we have this kind of silly example here, but I think it illustrates the point of a readability plugin, which just looks at, hey, the font size on this page is maybe too small, it's not legible, we should bump it up. So to get this functionality, it literally just takes about 10 lines of JavaScript. So first, we're going to add a new audit category called readability, and then we're going to inject the feedback that we want back to the user. So we're going to say, we found two styles with a small font. So I guess I should say that when you run this audit, you have access to the page, so you can do all of your logic, and then based on that, you would emit these rules. So we found two styles with a small font, and we can add a severity and other things, and all of a sudden you're looking at this nice report in Chrome DevTools. So you can find broken links, best practices, etc. Very, very handy. So if you find yourself repeating the same work at any point in time, this is the tool that you want to be using. Similarly, you can actually extend the panel in Chrome, which is to say, instead of just adding functionality into the audit panel, you can put it into other places within Chrome. So for example, we've just added this font picker panel, which can live in all the various locations. And you click on an element, you can have contextual control of that element, and you can actually inject additional properties like what is the font name and other things. So if you have your templating engine or some other framework, you can actually embed some of the additional functionality right into Chrome. Once again, quite nice. A little bit more advanced than the audit, but nonetheless, this is the right tool if that's what you're looking for. Now, this one's kind of interesting. I know that I've certainly spent, and I feel fine admitting it, that I spent way too much time customizing all of my various IDEs for what's the perfect, ideal color scheme and font sizes, etc. Good news, you can actually do the same thing in DevTools as well. I know that I certainly spend a lot of time in DevTools, and I like that to be consistent with the rest of the system. So you can actually drop in your own custom CSS to restyle all of the style sheets or all of DevTools. And you can check out these slides later. There's this link to a post that Adi put together, which has a lot of really cool and nice looking themes. You can just drop that in and completely restyle your Chrome DevTools, which is quite cool. And this applies on all platforms. Now, debugging is something that we get a lot of questions about, and this is a very, very powerful feature of Chrome. So this applies to both mobile and regular debugging. So there are two ways, basically, to leverage debugging. One is you start your Chrome instance with this extra flag called remote debugging port, and then you give it a port number. And similarly, when you're running on your phone, you just need to set up port forwarding. So for example, I have my Android phone. I can connect it to my computer. I have Chrome running on that phone. ADB is the Android debugger. So I'm just going to set up port forwarding, and then you can debug your web pages that are running on your phone, but directly in your DevTools. So let me show you an actual example here. So I'm going to start Chrome Canary with the remote debugging port 9222. I'm going to run this. It opened this guy right here. I'm just going to open google.com. So far, nothing too interesting. It works. Now, in this other tab, I'm going to do something interesting. We know that we're running the debugger on port 922. So if I just send a request to this /JSON endpoint, it actually returns me a bunch of metadata about all the open tabs And in here, you can see that the first tab that is open is, in fact, google.com, which is the page that we opened. No surprise. And we also give you this WebSocket debugger URL, which means that we can connect to this endpoint and start doing interesting things. And of course, at this point, you're probably asking, what are those interesting things? Well, if we go back, one thing you can do is actually take another client, which is not even necessarily DevTools, connect to it, or connect that tool to Chrome and drive it. So for example, here I have just a very simple Ruby script, which will actually drive Chrome and drive it through the debugging protocol that we support in Chrome. So let's take a look at what's happening here. We query this URL that we just saw. We fetch the first WebSocket debugger URL. So this would be our Google URL. And then we connect to it, and we just send a couple of commands. The first one is network.enable, which means that, hey, I want you to enable network debugging from this point forward. I want to get data for this. So think of it just as in your Chrome DevTools, you're clicking on the network panel. That's effectively what you're doing here. And then the next request, request number 2, I'm saying, hey, please navigate yourself. So I'm talking to the specific tab. Please navigate to twitter.com and search for DevTools. OK, so far so good. And Chrome will do that, and it will actually then spit out all of this network data. And how is it going to look? Well, it's going to look something like this, except there's going to be lots and lots more data. So for example, as we're loading Twitter, there's a lot of resources on that page. You're going to see a lot of requests coming in. Here's an example. We have a request that is being made by Chrome, and Chrome is logging this, saying, look, I'm making an XHR request. This is an AJAX request. I'm asking for the current trends in English language. By the way, I got a 200 for this request. I didn't use the cache. I didn't reuse the connection for whatever reason. And by the way, here's all of the timing data for this request, how long I spent connecting, doing a DNS lookup, and other things. So kind of very low level, but it's, once again, all the data you would need to construct your timeline or something else, which actually kind of hints at the next thing, which is Chrome DevTools itself is a web app. So once again, we have our Chrome Canary here. Let me just, so these two are two different versions. This Canary, and this is a regular version of Chrome. So we have the debugger running on the one on the right. So I'm going to go into here and go to localhost 9222. This is where we run the debugger. And look at that. We have the tab. We can see the tab that we have open, which is google.com. And if I click on this, it'll load up DevTools. And you notice that as I hover over the different elements, it actually highlights it on the page on the right. So this is one instance of Chrome talking to another. This is the same workflow that would happen when you're running it on your phone. We're just doing it with two side-by-side Chrome runtimes here. So why is this interesting? Well, this really highlights the fact that DevTools itself is a web app. And just to prove the point, we can actually open DevTools on DevTools. So if you're seeing double, that's as intended. Because, for example, as I hover, whoops, that's the wrong one. If I hover on this element here, right, you can actually see it being, so here I'm debugging DevTools on the right, which is debugging this page. So going a little bit meta here, but this is very cool, which means that you can take this code, you can actually modify it if if you have some really awesome improvement that you wanted in DevTools. We'd love to hear what it is. You can go right in, modify it, play with it, and do all kinds of interesting stuff. So let me close that. It can get a little bit confusing. Let's go back in here. So we talked about connecting to a debug endpoint. We talked about consuming the WebSocket feed, and in fact, DevTools, that's what DevTools uses. It connects to the WebSocket endpoint, consumes that data, and then just puts everything to the screen. But what if something else generated this debug feed? And this is an example I love to use. I think this is really, really cool. So guys at Square.com built this really cool open source project called Pony Debugger. And their observation was that, hey, we use Chrome DevTools all the time for developing our web apps. We'd like to use it for developing our native apps, our iOS apps. So what they did was they started emitting, they basically looked at our debug protocol, which is defined. You can actually find the docs on it. And they are emitting this data straight out of their native apps, iOS apps. And their apps are making requests through the network. So they're just outputting this data, and they're then connecting to this WebSocket endpoint with DevTools. And they can see all of the data as you would expect, all of the network waterfalls and all the rest. So this is iOS device emitting these events, and you're basically debugging it in Chrome DevTools, which I think is really, really awesome. And not only that, but of course, you also have core data in iOS. So they were able to hook up core data and use Chrome DevTools to drill in directly. So for example, you have user model, and user model has different properties, etc. So once again, this is Chrome DevTools being used to debug not Chrome, but something else entirely, which is awesome. Now, shifting gears a little bit, benchmarking. Benchmarking is a very hard thing to do right. Very easy to get wrong because you tend to forget something. And it's easy to forget something because there's so many different layers of caches, socket pools, and other things that are being maintained by your browser, by your operating system, your DNS caches, etc. So we have a very handy tool that can help you do this better or do it right. And to get that running, you actually need to install an additional extension. It's the Chrome benchmarking extension. You can install it from the Chrome App Store. And then to make use of it, you actually need to start Chrome with a new flag. So just like previously we were using the remote debugging flag, here we need to enable benchmarking. And what this allows the extension to do is it gives it control to be able to close all the socket pools, flush those, flush the DNS cache, all kinds of kind of internals of Chrome that you don't get exposed to kind of day to day. So combining those two together, they'll help you automate benchmarking. And I'll show you this in a second. One other tip that I have is this is specific to OS X, I should say. But if you're running on a Mac, there's this very cool app that's not related to Chrome at all, but called Appify, which allows you to take any sort of command with a couple of parameters and wrap it into what looks like an app. So it sounds simple. So I have Chrome Benchmark. I just packaged it as an app so I can run this. Actually, to do that, I'll have to quit this. So Benchmark. It'll start up an instance of Chrome. There we go. And so we're running with this flag, and the extension is right here. I'm going to load it up. And it gives me this interface where I can type in a couple of different URLs, or in fact, as many as you want. You can load an entire file. I'm going to just run this against two endpoints, so google.com and let's say yahoo.com. So you can specify the number of iterations. I'm going to say, let's say 3. We don't have all day. Clear connections, clear cache. I'm not going to test for speedy, but this can do a speedy check. So hit run and watch what happens. So now this extension is literally opening up these tabs, firing off these requests, loads the page, closes the tab, flushes everything, repeats this process, and it's going to do it 3 times for each of the URLs we've specified. So this is basically automating this experience. And the best part is that it aggregates all of this data and gives us a report afterwards. So, wow, the Yahoo pages are taking quite a while to load for whatever reason. So now we're loading google.com. And you can see that here we've had 3 runs in each case. As you saw, so we have standard deviation in the load time. So one of the pages took a long time. So the standard deviation is really high. I wonder what happened there. And we can also just click on these 2 guys and click compare. And you can see that the Google pages were pretty consistent. Something funny happened there. Maybe it was my network, but you can see the huge variation between these runs for yahoo.com. So you can put in more URLs. Definitely use this tool. It gives you nice metrics for things like load mean time, time to first paint, which is very handy, the mean time, and a number of other things. So very handy if you're doing any sort of benchmarking. This is the way you should do it. And speaking of the internals of the Chrome networking stack, there's actually quite a bit of data that you have access to if you're trying to debug the performance of your application. So we have the Omnibox, which, and this is kind of on the side, this is more of personal curiosity, if you will, but we have the Omnibox, which helps you with autocomplete and trying to help you figure out where you're trying to go. So all of this data is stored in Chrome predictors. So if you just grab this and type it into your Chrome and hit enter, you'll see all of the predictions that Chrome stores that you've typed, and you can see the guesses that Chrome will make, which actually makes for quite interesting to explore. The other section that I'll highlight is Chrome Net Internals. If you haven't played with this, you definitely should. There's a lot of useful tools hidden in here. So if I go into Chrome Net Internals, let me go into sockets, and here you can see all of the open sockets currently in Chrome. You can actually flush them, you can close them, you can do all kinds of stuff. You can look at your current cache, so timeline, DNS, the records that are being kept by Chrome. So all of this data is in here, and I'll show you one specific example for Speedy. So Speedy is a layer below HTTP. So it's when you look at resources fetched via Speedy, you actually won't see any difference in your timeline because basically it's just HTTP. But they do look different on the wire. So right now we have 2 Speedy connections open. And let me show you an example. So I have this really silly speedy.io, which just prints hello world. There you have it. We can go back into our Chrome Net Internals and look at that. We have a Speedy connection that is currently open to the server, and we have the ID of it. So we can click on this, and you see the actual session. You click on that, and all of a sudden you see all of the data as it is on the wire. So these are the Speedy frames being exchanged between the client and the server. So we're sending a SYN stream with all kinds of parameters. This should look very familiar. It's basically HTTP, but it is wrapped in kind of a different protocol. So if you're curious about Speedy, if you want to play with it, if you want to explore it, this is the place to kind of take a peek and learn what's happening. So let's close that and head back. Similarly, Chrome stores a lot of histogram data. So this is performance-related data specific to your browser. This data is collected throughout the lifetime of the browser, or since you opened it. So you can look at things like what is the average or the mean or what is the distribution actually of the DNS lookups. So if I open this, there's a lot of histograms in here, but if I look for DNS success, let me just look for success. Attempt success duration. So you can see that most of the DNS requests that I make get completed very fast. So within 0 milliseconds, which means they're cached, which is exactly what we want. But then there's this long tail, and then there's this funny spike at about 300 milliseconds. So this is the detailed histogram metadata about just your network performance. So if you have a suspicion that maybe your ISP or your DNS server is not working well, this is the place to find out. Lots of other data aside from DNS in here as well. So just fun to play around with. And last thing that I'll mention is, and this is more specific to Chrome. So some of these other things like socket pulls and other things are basically present in all the web browsers today. One of the nice features of Chrome is that it actually learns the topology of the network, or your site, if you will. So let's say I've never visited CNN.com. The first time I load it, Chrome knows nothing about it. So we just go about loading the page as you would. But we remember which subdomains or which domains we've used to fetch some of those resources. So for example, if you're putting a lot of your assets on some CDN and we're fetching a lot of resources, we'll remember that, such that the next time you load CNN.com, we will actually see if it makes sense to preemptively open that connection to your CDN, such that when you do make that request for the asset, we already have the connection open and it can be fetched faster. Now, it doesn't mean that Chrome will do that every single time, but in this example for Vita.com, you can see that these are the resources that we've remembered. We know that this page uses the Google fonts, it uses the plus button, and it uses Google Analytics. So we've remembered those, and next time around, we may actually use this information to speed up the performance of your site. So kind of very interesting and fun to play around with. And you can go into the DNS, Chrome slash DNS, and look at these host names and see what's happening there. Now, this last tool here is Chrome tracing. Very powerful, very interesting. It was originally built by and for Chrome engineers. So we were trying to figure out how to improve performance of Chrome, what's actually happening in the guts of Chrome itself. But a lot of people have started using this because it is in fact very useful, not just for understanding how Chrome works, but how your code interacts with Chrome code. So for example, if you're running or if you're writing a game or something that is really exercising all of the features of Chrome and really trying to leverage the GPU and other things, this is definitely something that you want to check out. And there's a great article on this on HTML5 Rocks, but let me show you what this actually does. So we can go into Chrome tracing. Whoops. Chrome tracing, we can hit record, and let's go to one of these tabs, and there we go. We'll just scroll around for a little while, go back, hit stop. Now we have a lot of different tabs open, so as you can see, there's you see the individual threads of each tab and how those are interacting. But right here we have a bunch of activity. So this is the renderer thread, and we were just scrolling and we had that kind of slow interaction. So the renderer was doing a lot of work in here, and we can actually zoom in on this region and see. So this is, or these are rather, the specific frames that are being rendered, and this is the work that's being done. So if we continue zooming in, we can pan around and we can see the actual work. So we have a render widget that's calling. So these are internal names within Chrome. So if you want to find out what Chrome is doing, this is fantastic. And we can continue zooming in, and we can see that at a specific frame here, we're actually drawing the pattern. So we're calling a function within Chrome called image draw pattern. And this is what's outputting those Chrome logos. But if you want to find out more as to how that works, perhaps you're trying to debug something, that's the way to do it. But not only that, this by itself is kind of useful because you get to peek inside of Chrome and figure out, maybe you have a performance bottleneck that you just can't figure out. That's the place to figure out what's happening. But even better, you can actually inject your own labels into here to figure out where is my code and how does my code interface with other code within the internals of Chrome. So to do that, in your app, you can use console.time and timeend to mark a start and an end point for any interval. And then in this case, I'm saying update. And if we repeated the same exercise and then zoomed in on that specific section, we would actually see these blocks here. So update and render. So this is your code running within the context of all the other code within Chrome. So if you're really pushing the performance of the browser, this is a great way to kind of get a full picture of, not just kind of high-level JavaScript API. And that will give you access to CPU, GPU, and many other things. So with that, that's all the tips we had for now. You can check out the slides, and I encourage you to do so. There's a lot of links that you should explore in there at bit.ly/devtools-tips. Thank you.